Hi students, welcome to CMOS classes. Analytic function. Here, when an imaginary part of analytic function is given, how to construct that corresponding analytic function we are going to see by an example. So this is the question. Find the analytic function f of z. F of z is equal to u plus iv. If v of x comma y is equal to sin x sin hy by cos 2x plus cos h 2y and f of 0 is equal to 1. This is the problem. See, they gave imaginary part because f of z is u plus iv. They gave the z. I want to construct this whose imaginary part is this. So what is given? V of x comma y is equal to sin x sin hy by cos 2x plus cos h 2y. To construct this analytic function, we are using Millen-Thomson method. We are going to obtain the analytic function by doing two steps. Step 1, we have to find Vx of z comma 0 and Vy of z comma 0. What is the meaning of this? And I want to differentiate this function partially with respect to x, and then I am replacing x by z, y by 0. Next, the same this function, and I am going to differentiate partially with respect to y and put x by z and y by 0. So after finding this, we have to apply these two in a formula where we can find this f of z. I am going to differentiate this partially with respect to x. Vx is equal to, which means that I am differentiating this partially with respect to x. So use quotient rule formula. We know the formula v u dash minus u v dash by v square. So v. So I will write the denominator term as it is. So cos 2x plus cos h 2y into differentiation of this with respect to x. Sin x will become cos x and this remains the same. So we will get cos x into sin hy minus uv dash. So sin x sin hy into differentiation of the denominator partially with respect to x. So which means that this term becomes 0 and this will become minus 2 sin 2x. The whole thing divided by v square. So cos 2x plus cos h 2y the whole square. Now in this one I am going to replace x by z and y by 0. So vx of z comma 0 equal to cos 2z plus cos h 0, hyperbolic function cos h 0, that value is 1, into cos z sin h 0. Sin h 0 value is 0. Here this minus and this minus will become plus 2. I will write front, and for this it is sin z. So 2 sin z sin hy again it's become 0 into sin 2z. Whole thing divided by cos 2z plus 1 the whole square. Vx of z comma 0 is equal to, now see I am going to multiply the entire term by 0. So this will become 0 and here also the entire term multiplied by 0 and this is also 0. And 0 plus 0 is 0 and 0 by anything that will become 0. So this value is 0. So Vx of z comma 0 is 0. Next we will find Vy partially differentiating with respect to y. The same quotient rule formula v u dash minus u v dash by v square, but here I am differentiating partially with respect to y. So I will write first v term cos 2x plus cos h 2y into sin x will remain the same and sin hy differentiation is cos hy minus, I will write this term as it is, sin x sin hy into differentiation of denominator, and this will become 0 and this will become 2 sin h 2y. cos h2y differentiation is 2 sin h2y. The whole thing divided by denominator cos 2x plus cos h2y the whole square. Now I am going to substitute x by z and y by 0. If I am substituting, this will become cos 2z plus 1 into sin z into 1 minus sin z. This will become 0 and this is also 0. Whole thing divided by cos 2z plus 1 the whole square. Will simplify further. This Vy of z comma 0 is equal to cos z plus 1 into sin z by cos z plus 1 the whole square. See here square the same term, here 1. So one term get cancel in the denominator and numerator, this term get cancel. Now we will have Vy of z comma 0 is sin z by cos z plus 1. So we found Vx of z comma 0 is 0 and Vy of z comma 0 is equal to sin z by cos z plus 1. We can simplify this. We know the formula cos 2 theta is equal to 2 cos square theta minus 1. So 1 plus cos 2 theta is equal to 2 cos square theta. So I can write sin z by 2 cos square z. So this is equal to, we can simplify this 1 by 2 into, I can write sin z by cos z into 1 by cos z. So 1 by cos z is secant z, sin z by cos z is equal to tan z. So Vy of z comma 0 is equal to half into secant z tan z. So now we'll move on to step 2. We have to write the formula to obtain f of z. This is the formula. F of z is equal to integral v y of z comma 0 into dz plus I into integral vx of z comma 0 into dz. So this is the formula. We found already Vx and Vy of z comma 0s. Substitute here. See, we found Vx of z comma 0 is equal to 0. Vy of z comma 0 is equal to half secant z tan z. So if I am substituting, this is equal to half into integral of secant z tan z dz plus I into integral of Vx of z comma 0 is 0 dz. This is equal to half into integral of secant x tan x secant x. So this is secant z plus complex constant c. See, we found f of z, but they given an initial condition to find this constant value. So when x is equal to 0, it is given that f of z is equal to 1. Therefore, this equation we can write half secant 0 is 1. So half into 1 half plus c is equal to 1. This implies that c is equal to 1 minus half, which is equal to half. So we found the value of c is half. Therefore f of z is equal to half secant z plus half, or I can write this as secant z plus 1 by 2. See, this is the corresponding analytic function of the given v, and this is the answer for this problem. For similar problems, subscribe and watch my channel. Thank you for watching.